Hello everyone, welcome back to my YouTube channel Unfog with Dr. Atahar Parveen. If you are new to this channel, please do subscribe to the channel, and if you like my work, please do like the videos and classes present in the channel, and also please share among other HSTR and teaching recruitment aspirants who are willing to write the teacher recruitment examinations. No, this channel is for you all. Okay, this channel entirely is dedicated for all the teacher recruitment examinations. Okay, I teach all maths and science. Okay, this class has been made by keeping in mind the syllabus of KVS also. Okay, actually the same syllabus is there for KVS TGT also. That's why I have made this class keeping in mind their syllabus also. So this class is going to be surely very much helpful, very much useful for KVS TGT aspirants also. Okay, not only HSTR aspirants, KVS TGT aspirants can also watch this class and learn this topic, because this is a very important topic. Okay, every time minimum 1 or 2 questions come from this topic. Okay, so in this class I'm going to discuss maths chapter SURDS. I know that many of you are so much worried about the notification. So like you all, I am also worried about the notification. But I am having some positive vibes, and the way the education minister is giving updates very oftenly nowadays, I am expecting HSTR notification very soon, within a month or so maybe. Okay. So before starting this class, let me quickly give you this phone number. Actually, many of you are asking phone number, right? Aspirants who want to enroll into HSTR PM method paid classes, you all are asking for phone number. So I have a phone number here. The phone number is 9900021027. Okay. Now I know that many aspirants are having some doubts regarding enrolling into my HSTR PM course batch 2 paid classes. So you all can call this number or WhatsApp to this number to get assistance in enrolling into the HSTR PM course batch 2. Okay. The fee, of course, it is rupees 3,500 for batch 2, and you can click the link given in the description below this video for QR code which is to be scanned to pay fee, and also you will get the tentative schedule with that link. Okay, that tentative schedule is nothing but the plan of this HSTR PM course. Okay, now if you are interested to join, please join as soon as possible, because already 5 days classes are conducted. Okay, but don't worry about previous classes. No, you should not worry. Once you get enrolled into HSTR PM course batch 2, you will be provided with all classes right from the beginning. Okay, all those classes are recorded classes, right? So you don't need to worry. I will provide all the classes right from day 1 till the day you are enrolled in. Okay, I will provide all those classes also, and as you will be enrolled, the future classes also obviously you will get. Okay, not only that recorded classes, you will also be provided with the PDF notes, study material and worksheets for mathematics wherever it is required. Okay, so all this will be provided along with the recorded classes. Okay, so you can call to this number for registration related queries. Okay, but if you have any doubts regarding the course, I mean to say, if you have course related queries, then please you will have to mail me only. Okay, because I am the one who can clear all your doubts related to my paid classes. Okay, so this is my email ID, atahartethstrcourses@gmail.com. So please look into the spelling. Many of you are writing wrong spelling, and then you are complaining me that I am not replying you. See, if I get your mail, I will reply you. No, so if you want to make sure that I am getting your mail, then please you make sure that you are typing the right email ID. Okay, and also you can join my Telegram channel. The link of the Telegram channel will be given in the description below this video. Okay, so that's it about the paid classes. Now let's start with our discussion of today's class, the most important topic, SURDS from mathematics. It is a HSTR syllabus based chapter. Okay. Basically, SURDS means if there is a square root, okay, if there is a number inside this square root, okay, if that number is a perfect square, then no problem, that number will come out of this jail. What is that jail? The jail is the square root. Okay, whenever I refer to jail in this class, no, I mean to say that that number is trapped inside the root. Okay, so if that number is a perfect square, it will come out of the jail. Okay, then that type of a number will be a rational number. But if a number is not a perfect square, then it should stay inside the jail only, right? If you want to bring it outside the jail, you can bring it, but then you will have series of numbers in its answer. For example, if I have 2 here, then what will be the value for this root of 2? You cannot bring the 2 outside the root, right? If you want to remove that root upon the 2, then you will get one series of numbers. There will be a decimal number, correct? It will not be an exact value. So such type of numbers are known as irrational numbers or SURDS. SURDS, okay? For example, square root of 2, square root of 3, square root of 5. These are all not perfect squares, right? They don't have exact values. So such type of numbers are known as SURDS, okay? I will differentiate between rational and irrational numbers, or for example, differentiate between SURDS and rational numbers. Basically, irrational numbers we call them as SURDS. Okay, irrational numbers are called as SURDS. Now, to differentiate, just to give you one good clarity, I am telling, see, this is a perfect square, right? Square root of 36. Okay, I can remove this square root. I can remove this 36 out of jail just by writing 6 here. Correct? In place of 36, 6 will come and the square root will vanish. Correct? Like that only for 144 also I can do. 12. Correct? These are our perfect squares, right? These are all perfect squares. So you can remove the square root and you can write the answer. But for root 2 and root 3, or maybe with some other root like cube root of 21, you don't have exact values. Okay, so such type of numbers are known as SURDS or irrational numbers. Now this chapter deals about SURDS only, so we will be bothered about the SURDS only, and our aim will be to remove those numbers from the jail. That will be our aim in the entire class today. Okay, that means our aim will be to remove the square root or cube root or any root from that number. Okay, I mean to say our aim will be to change irrational number into rational number. Okay, now that jail will be there, no, or that root will be there, no, that can be anything, right? That can be a square root, that can be a, I mean to say I don't need to write number here inside. I will just write a root here. That can be a square root, that can be a cube root, that can be a fourth root, that can be a fifth root, correct? That can be a sixth root also. So this number is there now with that root, that number is known as order of the SURD. Okay, for example, if you have a fifth root and some number is there inside, some integer, okay, so the order of the SURD will be 5 because it is a fifth root. Okay, if it is a cube root, then order will be 3. If it is a 2, I mean to say square root, then order will be 2, and that type of SURD is known as a quadratic SURD. Okay, quadratic SURD. We will deal much with the quadratic SURDs only. Okay, quadratic SURD means if there is a number inside a square root. Okay, now if you want to know more examples on a quadratic SURD, means any number you take, you write a square root above it, square root of 2, square root of 3, but that number should not be a perfect square. Huh? That should not be a perfect square because we are talking about irrational numbers. Okay, so this was about the order of a SURD. Now we shall have this example. Now you know what is the order of a SURD, you know what is a SURD also. Now one thing you should understand based on this question is what is a ascending and descending order. Ascending order means not only about SURDS, I'm not talking only about SURDS, any numbers or any variables with some powers, anything in mathematics, if you want to write it in ascending order, it means that you have to rearrange the given group of numbers or variables or whatever they are. You have to arrange them in a manner that you are writing them from smallest to largest. Smallest number to largest number. For example, if you want to arrange 1, 2, 3, 4, then if you write it in order 1, 2, 3, 4, it means that you have written from smallest number 1 to largest number 4. That is in ascending order. Okay. If you are told to write in descending order, then you will write the largest number first and smallest number last. Means 4 to 1. Okay. Ascending order means smaller to bigger. Descending order means bigger to smaller. This you should not get confused. Okay. I know these are very silly things. We should not take any point lightly, especially when we are attending a competitive examination, and that too if it is for job. We shouldn't take risk at all. Okay. So this is ascending order and that is descending order. Smallest to largest, largest to smallest. Okay. Now coming back to the problem. Now by seeing this problem only, I can say that I can write a square root of 2 like this. 2 to the power 1 by 2, and cube root of 3 I can write it like this, 3 to the power 1 by 3, and sixth root of 6 I can write it like this, 6 to the power 1 by 6. Correct. Now what is the order of each surd? Order of 2 is 2 only because it is square root of 2. Order of 3 is 3, and the order of this surd is 6. Correct. Now we would like to make something common in the powers to proceed and solve this problem, right? We want to make something common. Now easiest way to make something common is try to make a common denominator in the powers, because these powers are fractions, right? If I have a common denominator, then I can decide which number will be bigger and which one will be smaller. Okay. Now how to find the common thing? Very simple, our as usual historical older trick. Do LCM. 2, 3, 6. What is the LCM? 2 1s are 2, 3 as it is it will be there, and 2 3s are 6, right? So then 3 1s are. So my LCM will be 2 into 3. LCM will be 6. Okay. Now I will take this LCM 6 and I will try to make the denominator as 6 for other two powers. For 6 already 1 by 6 is the power, right? I will try to make 1 by 6 for 2 also and for 3 also. Okay. So let's try to do it. For that, what we have to do, we will take first number 2 to the power 1 by 2. In that, what I will do, I want 6 in the denominator in the power, right? So I will multiply it with 3 because 3 2s are 6, right? So this will give me 2 to the power 3 by 6. Okay. Like that only I will do for 3 to the power 1 by 3 also. I'll multiply 2 by 2 now. Why? Because I want 6, right? 3 2s are 6. So 3 to the power 2 by 6 I'll get. Okay. Now 6 to the power 1 by 6 is as it is. I don't need to rewrite it because now for me powers became common, right? Now what are the numbers for me? They are 2 to the power 3 by 6, 3 to the power 2 by 6 and 6 to the power 1 by 6. Now I can also write this number as like this, right? 8, because 2 cube is 8, right? 8 to the power 1 by 6. Or I can also write this number as 9 to the power 1 by 6 and this number as 6 to the power 1 by 6. Now it has become so easy for me to arrange these numbers in ascending order, right? If I arrange these numbers in ascending order, how I will arrange? 6, 8, 9, correct? Like that I will write here also. 6 to the power 1 by 6, 8 to the power 1 by 6 and 9 to the power 1 by 6. Now this is my ascending order. I have rearranged the given numbers in ascending order. Now if I see in the options, I don't have anything like this, right? 8 and 9 are not there only. Only 6 is there. So what I will do, I will go back to my question and I will see which number came from where. Okay. This 6 to the power 1 by 6, so it is as it is. Next number 8 to the power 1 by 6. It came from this 2 to the power 3 by 6 or a square root of 2. Okay. Square root of 2 is nothing but 8 to the power 1 by 6. So I will write it like this. I will write it like this. 6th root of 6. This I can write it as a square root of 2 and this number I can write it as cube root of 3, correct? Because 9 to the power 1 by 6, it came from middle number, right? 3 to the power 1 by 3, right? So 6th root of 6, square root of 2 and cube root of 3 means it is option B. That will be the correct answer. Okay, so this is how you have to do. What we have done LCM. That is the main step. If we take the LCM, then we are done with the answer. And little bit we should be careful while ticking the option, because though this was the correct answer, this was not there in the option, right? So we had to redo it, and then we had found the correct answer from the options. Okay. Another similar type of example. The question is 4th root of 6, square root of 2 and cube root of 4. Okay. Let us see the order first. It is 6 to the power 1 by 4. It is 2 to the power 1 by 2. And it is 4 to the power 1 by 3. Order is 4, 2, 3. So LCM will be 12. Okay. Now our aim is to make a 12 common denominator for the powers of these given numbers. Okay. So for that, what I will do, 6 to the power 1 by 4, I will multiply with the 3 and divide with 3, so that I get 6 to the power 3 by 12. Like that only I can do for 2 to the power 1 by 2. I will multiply it with 6 because 6 2s are 12, right? So 2 to the power 6 by 12. Next I will take 4 to the power 1 by 3. Multiply and divide it with 4 because 4 3s are 12, right? So 4 to the power 4 by 12. Now if I write, it will be like this. Now after writing this with the common denominator in the power, I can also write this as 6 cube whole to the power 1 by 12, right? And this I can write as 2 to the power 6 whole to the power 1 by 12, right? And again this 4 to the power 4 whole to the power 1 by 12, right? So now inside these brackets, 6 cube, it is 216 whole to the power 1 by 12. Next 2 to the power 6, it will be 64 whole to the power 1 by 12. Next 4 to the power 4 means 4 4s are 16. 16 into 16 will be 256. 256 whole to the power 12. Now I can easily write it in the ascending order, right? It will be 64 whole to the power 1 by 12. Next will be 216 whole to the power 1 by 12. Next will be 256 whole to the power 1 by 12. Okay. So first number, this number, it came from a second number actually, root 2. So I have to see which is the correct answer. It should be either A or C. For the second number, you see 216 to the power 1 by 12. It came from first number actually. It is fourth root of 6, right? It is the fourth root of 6. Okay. So root 2, fourth root of 6. Next is the cube root of 4. So option A will be the correct answer. Okay. So what we have done? We have written it here in ascending order. Okay. Now coming to types of SURDS, actually there are many types of SURDS. In that like SURDS and unlike SURDS will also come. Like SURDS and unlike SURDS. Like SURDS means they are those numbers which will be same inside the root. A root is there, no. You will have root 2 means in all other SURDS also you may have root 2, but number will be, the outside number will be different. It may be like this. Okay, or it may be like this. So these are like SURDS, means the number inside the root will be same. That are your like SURDS, and if it is not same, they are your unlike SURDS. Okay. Now there is one more type of SURD which you call it as a compound SURD. Compound SURD means it will be group of 2 or more SURDs. Okay, you will have 2 or more SURDs in that group, and between those SURDs there will be either addition or subtraction. Okay, either there will be plus or there will be minus between those group of SURDs. That group is called as a compound SURD. Okay. Particularly in that compound SURD, if you have only 2 SURDs, exactly 2 SURDs if you have, no, exactly 2 SURDs, that type of compound SURD you call it as a binomial SURD. Okay, so we will deal with the binomial surd only maximum number of times. Okay, so these are the types of surds. Now, how to solve problems related to surds? Actually, there are few rules which will make things easier for us to solve problems based on surds. For example, first rule is if you have a pattern like this, if you have a surd like this, square root of a into b is there, then you can find the solution by writing it as square root of a into square root of b. You can split it easily. Okay, so it will be equal, both will be equal here. For example, if you have square root of 18. Now what is our aim in this chapter? Our aim in this chapter is to remove the number from the jail, right? We want to remove it from the jail called root. So our aim will be to remove this 18 from that jail called root, right? We want to remove that 18 from that root. But we cannot remove it because it is not a perfect square. Had we had a 16, then I could have easily made it 4 and I would have removed it from the root. But 18 is there. I can't do it. But what I can at least do is I can write 18 as 9 into 2 so that 9 is a perfect square and at least 9, some part of the number can be removed from this root. Okay, I can write 9 2s are 18. If I don't get what number is to be written inside in order to remove some part of that number from the root, I can do LCM always. LCM is always a regular procedure to do this type of things. Okay, I can start with 2 because this is even number. 2 9s are 18, 3 3s are 9. I have 2 3s, means I will have 3 square. If I have 3 square, I can remove 3 from the square. Correct? Square root. Correct? So I can write it like this, 3 square into 2. Okay, or I'll remove 3 outside. 3 root 2. Okay, now what I have done, I have written 18 as a 3 square into 2 and I have removed 3 outside. Basically, I have multiplied it, correct? Okay, another rule, it will be like this. If you have square root of a by b, you can split it like this, square root of a by square root of b. You can write it like this. Okay, for example, if you have square root of 12 by 121. Now 12 is not a perfect square, so what I can do, I can do LCM and see I have 4 3s are 12. So I can write it, I can use first rule, root of 12 can be written as 4 3s are 12. Okay, in the denominator 121, I know that 11 square is 121, so I am happy with the denominator. I have square here. Okay, I have square root here. For 4 into 3, what I did, I have used rule 1. Okay, now I can remove this 4 outside easily, right? So I will remove this 4 and I will make it 2 because 2 square is 4, and here in the denominator I can write square root separately. This is my rule 2, or I can write it as 2 root of 3 by 11. This will be the solution to square root of 12 by 121. Okay, I hope you are getting. So these are the two rules. One is for the product of surds. The second one is for the division of surds. Okay. Now, if you have a question like this, for example, if they are telling you to find the product of square root of 2 and cube root of 4. What you do, you can use rule 1 easily, correct here. See, 2 to the power 1 by 2 into, what is 4? I can write 4 as 2 square, right? Whole to the power 1 by 3. Means I can multiply them, correct? Now here, to do the next step, I have a law of indices. One law is there where we can multiply the two bases. If you have two bases, you have some different power, then you can add those powers if the base is same. Okay, if you have a into a and your power is n and m, then you can add n plus m, you can do that thing. I can apply here, correct? First I will make the bases common for that. So this I can write it as 2 to the power 1 by 2 into 2 to the power 2 by 3, because the 2 into 1 by 3 is 2 by 3, correct? Now I have bases common, so I can add the powers. 1 by 2 plus 2 by 3. So this will give me 2 to the power. What will be the LCM? It will be 6. Here I will have 3 and here I will have 2. So this will give me, not 2 actually, I will have 4, correct? 6 is the LCM, so 3 ones are, 3 twos are, already 2 is there present there, so 2 twos are will be 4. So this will be equal to 2 to the power 7 by 6. Okay, so if you have an option where this number is there, you can take that answer. Or if you don't have, then you will have to do something. What you will have to do? It is 6th root of 2 to the power 7. So you will have to multiply 2 7 times. 1, 2, 3, 4, 5, then 6, then 7. If you multiply, you will get 128. Okay. So this will give you your answer. If this is there in the option, then you have to take that answer. Okay. Another similar type of example. If they are telling you to find the product of cube root of 4 and cube root of 2. Okay. Into will not be there if they are asking product, right? So like this. So here also you will have to use our indices formulae. So I have given you the list of formulae here. These are very important actually. Okay. You will be using it in many places. Even in algebra you will be using anywhere. It's no necessary that it should be a variable. This x, it can be a number also. Okay. That is the formula we have used just now. Here also we are going to use the same formula. Now I can write it as 4 to the power 1 by 3 into 2 to the power 1 by 5. Now I want to make common bases. So what I will do? I will write like this. 2 square whole to the power 1 by 3 into 2 to the power 1 by 5. Or 2 to the power 2 by 3 into 2 to the power 1 by 5. I have common bases. So I can add the powers. 2 by 3 plus 1 by 5. My LCM of 5 and 3 will be 15. So I will have 15 in the denominator. In the numerator, I will do it like this, right? 2 by 3 into 15. Again, 1 by 5 into 15. I'll do it like this, right? So 3 ones are, 3 fives are. This will be 10. 5 ones are, 5 threes are. This will be 3. So here I will write 10 and here I will write 3. So this will be 2 to the power 13 plus 15 by 15. This will be my answer. Okay. So you will have options A, B, C, D. You will have options. In that, if there is a tough number like this, no. I am sure that they will give a number like this only. They will not tell you to simplify further if you have a tough sum like this. Okay. I mean tough number like this. Okay. Maybe here they will give you 3 by 5. Here they will give you some 1 by 5. Or here they will give you 12 to the power 2 by 3. Something like this they will give. So your answer should be 2 to the power 13 by 15. Okay. So this is how you have to do product of surds. Okay. Okay friends, this was all about part 1 of surds chapter. Soon I will post part 2 of this chapter as well. Okay. I really hope that you enjoyed this class and this was an important class. Okay. So if you are new to my channel, please do like, share and subscribe to my channel. And please share not only this class, all my free classes which are present in my YouTube channel. Please share them with as many PM method candidates. Okay. For more such free classes, please share all the free classes available in my YouTube channel. Okay. Thank you. Bye.